Today's problem, we're doing a ball launched straight up in the air with a velocity of 55 meters per second. What we need to find is what is the maximum height and at what time is it at its maximum, and how long the entire trip is. To start off, it's a good idea to draw a little photo of what we know. So, we know that our initial velocity is 55 meters per second. We also know that at this point at the top, the highest point, it'll have a final velocity of 0 meters per second. Now what we already know is that the acceleration, gravity, is negative 9.8 meters per second squared. Now the first step to do would be to write down our two equations that we know. One of our equations is the acceleration, which is acceleration equals final velocity minus initial velocity over time. Our second equation is distance equals initial velocity times time plus 1/2 times acceleration times time squared. Now, we do realize that we have only certain information from both of these problems. We have our accelerations, we know our 1/2, obviously. We know our initial and final velocities. The only thing that we are missing is our times and the distance. It is clear to use this equation first to find out our problem. So first step we would do is trying to find our time, which is not provided. To do that, we will use the first equation, except changing it just a little bit. We will use time equals final velocity minus initial velocity over our acceleration. And I'm going to put the numbers in on this equation right next to it. So we have time equals 0 minus 55 meters per second over our negative 9.8 meters per second. And now it is time to do our dimensional analysis part of it. So we have our time equals our negative 55 meters per second times our negative 9.8 meters per second squared. Now, in this dimensional analysis, we know that our meters will cancel out, as well as one of our seconds. So we will just be left with our seconds, which is a good thing. Now, doing the math, negative 55 divided by negative 9.8, which the negatives should also cross out, so you're left with 55 divided by 9.8. You should get time equals 5.61 seconds. And for this problem, we'll be rounding everything to the nearest hundredth. So for this time here, we know that our time from the half mark is 5.61 seconds, which is part of the problem that we're doing. So we know here that our time is equal to 5.61 seconds. The only thing that we need to find now is the highest point here, which we still don't know. That's okay. We'll use the time to do the second equation. Now that we were able to find the time using this equation, we will now be able to plug in the time for both of these two t's to find our distance. And to do that, we will use our distance, but I will write that out in our numbers and plug them all in. So we have our distance equals our 55 meters per second. Just going to put the time in parentheses, 5.61 seconds plus our 1/2 times our acceleration, which is negative 9.8 meters per second squared. And then also, I'm just going to write down here so I have room, is our 5.61 seconds squared. Now, I'm going to put this in dimensional analysis right here underneath. So it should be distance equals 55 meters per second over 5.61 seconds. Just that one. There's blank. Plus, don't forget the plus, 1/2. Just going to erase that now. And then we have our negative 9.8 meters per second squared. Now we're also going to do our 5.6, which I erased over there, and we're going to write this twice. 5.61 seconds. There's going to be another one on the side there. Is our 5.61 seconds. Goes on the side here. Now, our dimensional analysis, you could use your units. Our seconds on the left side will cancel out, as well as our seconds on the right side will cancel out, leaving us with the meters, which is what we want for our x. Make sure that you plug in 55 meters times 5.61 plus 1 times negative 9.8 times 5.61 times 5.61 divided by 2. And your answer for our distance should be 154.34 meters. This is going to be our maximum height. Already, we answered 2 of our 3 problems. We know that at this point here, our time is 5.61 seconds, and we now know that our maximum height is 154.34 meters. Now, we need to find our returning trip. Let's erase this. Okay. So, I'm just going to draw this out even more clear, just so we know. So we have our final velocity here, the initial velocity of 55 meters per second. Same, our acceleration is equal to negative 9.8 meters per second squared. And we have our time over here. And I'll make this dotted just so we could see what we're finding next. That's a halfway point. We know that our final velocity here equals 0 meter per second. Our time equals 5.61, and our x, our distance, equals 154.34 meters. So now it's real simple. We're going to have to use our distance problem to find the time from this point here, the halfway point, to our ending point. And to do that, we will use the equation again. Distance equals volume initial times time plus 1/2 times acceleration times time squared. Now, in this case, starting from this point here, we are starting from the top and going down. So our initial velocity is no longer 55, and our final is no longer 0. Our initial velocity will be 0 meters per second. So 0 times our time, that automatically makes that 0. So in actuality, we are solving for distance equals 1/2 times acceleration times time squared. Which is what we're going to use. We're going to take this equation and make it into our new one, which is radical 2 times the distance over acceleration. The radical takes care of our time. So time equals radical 2 times the distance over acceleration. The radical takes care of our our time squared. So plugging this in with our numbers, we are going to be using t equals radical 2 over, and this is going to be blank, over, next to negative 154.34 meters, blank. And the reason why we're using a negative is because we're going from this point downward. So it can't possibly be traveling up another 154.34 meters. It is traveling downward. And then we are going to use our negative 9.8 meters in seconds squared, the acceleration right next to it. And we should be able to use our dimensional analysis to cancel out our units. So our meters cancel out, as well as our negatives cancel out. And we are going to have just left is seconds squared, which is okay because the radical will take care of that. So by doing 2 times 154.34 divided by 9.8, we should get time equals radical 31.50 seconds squared. Now I'm just going to rewrite this up here, right here. So what should happen is we should get, after we do our 31.50 over the radical, we should get t equals 5.61 seconds, which is good, which means that from this point here, our time it took to go from this point to here was 5.61, and it traveled 154.34 meters. That means that from this point here back to 0 at the ground, it'll be 5.61 seconds. So that means what we can do is we can easily take our t equals 5.61 seconds, and we could times this by 2. So you get 5.61 times 2 to get a nice 11.22 seconds as our total trip. So this is going to be the total time. So now our answers are all completed. We have what is the maximum height. We knew it is for max height. We know it is 154.34 meters. And what time is it the maximum height with time? We know it is 5.61 seconds. And how long is the entire trip? Well, we just figured that out by doing time of total trip. Time total is equal to 11.22 seconds. And that's how you answer a problem that is straight up and comes right back down. Very simple, just by using your two equations of your acceleration and your distance problem. And that should be it.